So here's how we undo these things. So if we have, again, sort of, if you know Fourier transforms, maybe good to sort of think of them a little bit on the side, just how that kind of works, right? So you go from, say, a time or spatial dimension into a frequency space, and you can come back. But those transforms are similar, right? They're if it's continuous, they're integrals. If it's discontinuous, then you have sums and so on. You know, Laplace transforms are different things, and Mellon transforms are different things. So in this case, to undo this thing, there's sort of an iterative, or just kind of almost like a little algorithm. But it's, again, a bit of a sneaky thing to do. So we're going to differentiate with respect to, right, so it's different to this. We're just going to differentiate with respect to x, k times. And so what that's going to do, if you have your, right, you have your series. Yeah, so we have, I'll write it as P0, I guess, but we have f of x. The red is abusively, right, okay, we have f of x equals P0 plus P1 of x plus plus P to the k, P of k, x to the k plus plus these guys, right? So if we differentiate this k times, I shouldn't write like that, k, right? F of x. So all of these ones here will be disappeared. Yeah, fair enough. And we're going to get k. So it's k is going to come down, then k minus 1, then k minus 2. So we're going to get k factorial times p of k. And this will be x to the 0 by that point, which is, of course, 1. And then we're going to have terms that, so it's blob. It'll be p of k plus 1 times x to the 1 plus right? So there'll be factorials with, so this, for example, would be, let me get that right. So it's going to be k plus 1 factorial, and I guess that's true, right? You'd write divided by 1 factorial, perhaps. Okay. So if we set this to 0, x equal to 0, then all of these guys go away, right? And we end up with equal to k factorial pk, right? So this is a little thing that strips out what we want, and then we just have to divide by k factorial, and we've got our pk. So this is not a, you know, it's not great, right? I mean, this is a bit of a struggle, potentially. You'd have to like really work at this to undo the thing. So ideally, you find a form from the thing. What is going on? I'm here to help. Yeah, that's right.
What's the second?
I'm being paid to obfuscate. Sorry.
What's under k plus 1?
That's a good question. That's a 1 factorial. Because out here, and you can dangerously making things up on the fly. So this would be, so for example in here, you would have started with, it starts with x to the k plus 2, right? This is the p of k plus 2 term. So it starts with x to the k plus 2. So you're going to bring down k plus 2, then k plus 1, then k, right? All the way down. You've differentiated k times. So there's still right, you would have brought it all the way down. The last one you would have brought down, if I get that wrong, so the last one you would have brought down was a 3. Is that true? Yes, so that's good. Yeah. Right, so there would have been, as you're differentiating, you differentiate down, k plus 2 comes down, because you started with x to the k plus 2, You get to x cubed, you differentiate that, and then you get stuck at x squared. So, you know, there are these two that if you differentiate 2 more times, then you're getting this one out. You'll get x to the 0, that will cancel this, and it will look it'll look the same, right? Blob factorial p of blob. So I was just trying to write down, I mean, I lazily wrote blob, and then I was trying to write the right thing. Did I write the right thing, humans who are watching me? Okay. So this is our little undoing spell, right? This is all these things are charms and spells. It would be much better if we thought of it like that, right? And it comes out. But it comes out a bit sludgily, right? This is not terrifically easy, right? You're differentiating things. This is you'd have to use something symbolic if you wanted to. You see this in papers sometimes. They'll get something, this will have a nice form, but it isn't easy to extract. But of course you can differentiate things. So you just do it, and then you get some horrible sequence of stuff, and someone uses Mathematica, and page 4 is just like, and our understanding is not so great. You're still not happy. This thing? Which one? This thing?
No, the one on top.
This one?
No, the one on top. D to the K.
This thing?
Because it's like a derivative.
Is that a bad thing to do?
We're taking the derivative.
K times, yeah.
Oh, K time. Okay.
Yeah.
Okay.
I know this is sort of just the way it's not, because these things,
Taking the derivative of K.
I mean, it'd be nicer to write like that. But this is a convention. Am I in the wrong country? People write this, right? But in some ways this would be, a little bit better because it sort of frames as an operator and there isn't some funny little thing. But yeah. It is, yeah, like d squared dx squared, you see it like that. Maybe curly bracket, the big parentheses were hard to, people didn't have it when they were typesetting with blocks. Yeah.
What is x equal to 0
Yeah, so here's the game again. So oh, no. I have to do this. Yeah, I have to wake it up. Oh my God. I do get confused. I think I've started to try to move things on the wall. Can't do that. Okay, so the safety thing is to do that, and then it will. If we get time, we'll super wrong, but we should play this game, which means I'll play this game and show you. There's no time. It's Alto. Alto, anyone play this? Primo, beautiful game. Anyway, there's Alto's Odyssey on the sand, really nice. This is for psychological purposes, yeah. I mean, I gave up video games a long time ago to try and do things. But this one is an exception. Okay, so the point is you set x equal to 0 because that's going to crunch all of these guys. So what the derivative gets rid of everything with a power less than x to the k, because it just, right, indexes down, and eventually you get to x to the 0, and you differentiate that, and it goes boop. So this makes all of those things, this makes everything up to k minus 1 disappear. That's that job. And then the job of this thing is to get rid of the ones afterwards. Yeah. So you've got this long, you've got this function, and you want to do something to it that pulls out the kth element. And there are two very different little mechanical things that do that. One is this differentiator thing, which gets rid of all of the first ones, and then the 0 goes, and yeah. And this is some function, it's just something, you do a mess everywhere, it's like maybe a ratio, it gets worse and worse, and then you get all these terms. So it's a bit of a nasty looking thing, but you make Stephen Wolfram do it. I wish that was true, actually. Like, you have Wolfram inside and making him sweat. No, clever, very clever Wolfram. Okay,